Good morning, everyone. My name is Jayaprakash Ramakrishna. Today we're going to be talking about performance engineering in cloud environment. So this is basically based on the couple of demands as well as the request what we got based on our initial first webinar we went live with during February earlier this year. So let's get started with what does it constitute to do performance engineering in cloud environment. At a very high level snapshot, how different is the performance engineering in cloud different from a regular traditional client-server environment? So performance engineering in cloud constitutes load and performance testing, which is basically performance testing your application based on the actual scalability as well as reliability, and stress testing to make sure that your application can withstand the peak loads. Peak loads could be either during the early mornings, lunch hours, as well as during the late evening hours. And also latency. One of the biggest components of engineering in cloud is the latency. And the latency could be classified from the network latency, the end user web latency, as well as the different components in the system which actually relay so that an end user does not experience a lot of delay. Browser performance is one of the key aspects of any performance engineering. So at the end of the day, we just need to make sure the end user experience is very critical. So from a browser performance, we actually look into the end user experience. It could be how the pages are loaded, how the frames are rendered to the end user, depending upon the kind of connections what they have, the kind of GIFs, pictures that kind of get downloaded, as well as the design aspect. One other additional component is the security. So the security could be categorized in two main categories. One is security at an application or a product level. It is more focused on the actual end user privileges in terms of groups, kind of admin privileges, user privileges, and so on. The other part of the security is the actual penetration testing, making sure that your application or a product is not hacked. I mean, you have the right firewalls, right SSL certs, and the right security in place. And one of the last components which is categorized as others is one of the main important components. Basically, it covers the availability, failover, failback, data integrity, backup processes, disaster recovery, interoperability, privacy and confidentiality is one of the key focus. And also looking at the geographical location and also the distribution from where your application or a product is being accessed throughout the landscape. So this picture kind of like depicts an application in a cloud in its simplest form. So what you can see is in your product or application deployed in cloud could constitute of a firewall, load balancer, web servers, application servers, and a database server. So this is not a very high complicated landscape, but then again, I would like to use this as one of the examples as we walk through identifying bottlenecks and walking through the engineering process. So users generally access the application on cloud. So one of the key things to differentiator in terms of performance engineering cloud is basically having your application in cloud is one. The other aspect is also generating and simulating the load onto your application on cloud is one of the key factors. On a performance engineering framework, they're broadly classified into four different phases. One is the planning, develop, execute, and analysis. In planning phase is one of the key important phases in any performance engineering. You actually define the performance test strategy, define your test objectives, document business scenarios, test environment and tool setup. test data. So one of the key aspects of any planning is the strategy. In the strategy, you got to be able to model your test scenarios. When I talk about test scenarios, it's like depending upon your target users on your application, you need to be able to understand, document, and script the right set of actual users. And also, depending upon what state of your application, if it's a greenfield application deployment into your cloud, which is for the first time, I mean, you really do not have much of modeling to do in terms of the real end user data, but then you do an assumption in terms of how your application is going to be used in real time. But if you already have an application, we could use a lot of data from the modeling. And you define your scenarios. Once you define, you actually have to make sure as part of your development, you define your business scenario metrics. So what business scenario metrics basically talks about is your application could be having 10 or 15 different kind of end users. Scenario metrics defines what percentage of each of those end users would actually be constitute as part of your end user load scenarios. You create your scripts, and creating scripts is one of the key aspects. You got to make sure the scripts, what has been created, replicates an actual end user scenario. Basically, you need to be able to handle the dynamic values. You need to be able to correlate all the dynamic parameters that are passed on back from the server to the end user. And also the search, in case if there are search or adding something to your shopping cart and so on, you need to make sure it's all dynamically parameterized so that it mimics the actual real production load. And the other aspect is just before getting started testing, you need to make sure you have the right configuration tools and monitors in place. One of the major components to monitor is basically the load on the server in terms of load balancers to see there is an equal distribution of load, as well as capturing the right memory and CPU utilization at your servers, the right threads, as well as how the threads are growing, looking at individual garbage collection cycles to identify memory leaks, as well as the database monitors to look at the logs, concurrent sessions, and open sessions, and so on. So just before you get started, start with executing your performance testing, you ought to make sure that the single user test is kind of like validated. Make sure your end-to-end functionality works. It's not just about adding n number of users on the system. It's also about validating the actual functionality from hand to hand is still intact under load. So you validate that, you actually capture your transaction system logs, monitor your resources, and so on. The other factor, once you get started with the initial testing, you also have to focus on the failover testing and disaster recovery testing to ensure that if, going back to the earlier picture what I just showed, you got to make sure what happens if one of the servers is down. I mean, does the failover actually happen? How are the load distributed? What happens to the existing users who are actually connected on a sticky session to one of these servers? You need to make sure you document those things, you test those things as you proceed. So analysis of any performance testing is one of the key areas. So when you try to analyze the results, I mean, there are various aspects to look at the results. But to begin with, you always try to begin in terms of, okay, what does my end user transaction times look like? So a transaction is basically depending upon what it's nothing but you post a request and you get the response. So based on that, depending upon what your benchmarks are or what you plan to define your benchmarks as for a typical web-based application, you start drilling down into some of the aspects of bottlenecks. So the bottlenecks could be categorized at three broad levels. One is at the system level, which is more concentrated towards the configuration at the web layer, the app layer, the load balancer layer, as well as the database layer. And those are pretty much most of the configuration settings. The second part is also tuning of your application in terms of identifying bottlenecks at the application layer. Like, does your Java application, is the JVM well tuned enough to exploit the actual physical horsepower of your infrastructure? And the other aspect is also to look at the database part. So in the coming slides, we will look at some specific example. This is based on the real case study what we have done. I will focus on the JVM part, identifying bottlenecks in the JVM layer. We'll take an example. We'll walk through the example. I also will walk you through in terms of how we identify and we fix the issue. So again, coming back to the high-level application snapshot, we analyze the bottlenecks as well as the latencies as different layers: browser analysis, latency, web and app, server and monitoring and tuning, and database monitoring. So at the web and the latency part, we analyze bottlenecks at web design analysis, HTTP traffic analysis, and the core aspect of any analysis is basically making sure the end user experience is pleasant and it actually meets the requirement. Load balancer and failover testing. Also looking at the latency and bandwidth analysis in terms of browser, in terms of the middle infrastructure stack, as well as the network analysis. And WAN simulators are being used to simulate load in the cloud to make sure that the kind of requests that are sent to the server are based on different bandwidths. It could be the dial-ups, it could be the broadbands, it could be the T1 lines, and so on. And also one of the key concept on simulating the actual real-world scenarios would also be the IP config, which actually simulates the data as if it's coming from like hundreds of physical systems rather than just from one particular IP address. So IP spoofing is critical for actually simulating the real-time data. So in terms of web and app server, especially when it comes to the JVM tuning as well as identifying bottlenecks, the memory leaks are one of the key areas. In the coming slides, I'll walk you through with an example why memory leak is key. Also looking at the GC algorithm, the garbage collection algorithm, which actually basically suits your application, the way it has been coded, how the classes and methods have been used. Configuration review is key as well. Identifying the root cause, optimization of resources, and application profiling is one of the key things. When we see if an end user transaction response time, let's say it's like about 50 to 60 seconds at a very low load, drilling down to identify where the actual bottleneck is takes a while. And also having the right tools and the right method helps you identify those auth methods and the objects in your JVM layer so that you can actually better tune and optimize your application. At a database layer, again, AWR report analysis is very key and it's pretty extensive. And also the logs, connection pool size, SQL analysis in terms of how many round trips has been made, as well as how many times a particular SQL and the join statements are called, kind of like becomes very critical. And DB parameter analysis is one of the key aspects. So as part of our example, we are going to look at, so this is based on the actual case study what we did on some of the performance engineering on one of our healthcare systems. So what we looked at is at the JVM layer, we noticed a very high heap utilizations on servers. The actual heap size allocated to the server, the start and was like about 4.5 GB, but then again, the heap was being 90% utilized, and then even though there were frequent garbage collections, heap memory was not being released. So the impact was basically it used to cause memory leaks, and after a few hours the server would fail to respond to any end user requests. So based on the analysis, so we did, I mean, there are multiple ways of analyzing the heap dump. So what we did is we took an heap dump during our testing, and we also hooked up a JRocket Flight Recorder. It's a tool, a freeware from Oracle JVM, but again, it only works on the JRocket VM. So we generated the reports, and when we looked at the actual objects that were captured, we identified there were a lot of large objects that were part in the memory, but then again, when we looked at the GC cycles, this memory was not being released. One other example is we also looked at some of the queries that were happening at the database, and we saw too many SQL queries and multiple join statements. In one of our specific healthcare example, we were looking at bringing up certain specific plan depending upon the age criteria and as well as the regional location. We saw just to load up a few plans, it was making a lot of SQL calls, a single SQL call with multiple join statements, 56 round trips. Again, the impact was the transaction response times were very large. I mean, for a single user, it would be like about more than 10 seconds. Of course, scalability issues when you actually start scaling users. So in this slide, we just, this is basically the heap dump snapshot, which was collected during our tests, and the viewer is the Eclipse. So if you look at the chart, I mean, in the pie chart, you see like 80% of the actual memory, 3.4 GB, is occupied by one particular object. So we looked at what that object is, and when we drilled down into the actual object, we identified that there were a lot of objects within the framework that were actually occupying more than 80%, which again, in this particular slide, you can see on the right hand side, there were like about 70 MB of object sizes. So this particular picture shows you the diagnosis in terms of what does it take and how does it really matter looking at individual GC cycles. So if you look at the chart, the blue is actually the heap usage over a period of time during our testing. The green represents the actual live objects. So when we talk about the live objects, as you all know that during any GC cycles, there are a lot of live objects within the GC cycle. And once the reference for that object is released, the object is supposed to release the memory. So we saw way too many live objects. And if you look at the old collection as well as the young collection, we did identify quite a few objects that were not really releasing the memory. So as part of the latencies and diagnosis, if you look at this particular chart, you can actually see there were issues at the Java socket layer. It's basically the socket layer were not good enough to accept that many connections. One reason being is there was no memory. The second was the configuration setting for the concurrent sessions at the JVM was not optimized. So this is another view basically based from the Eclipse view. So you can see the highlighted one. Before the heap issue was fixed, we were like about 83% of the utilization. This chart shows you the actual heap snapshot after the fix. I mean, after the fix, it was basically a configuration and certain setting fixes that was put in, and then the heap utilization kind of like came down by like almost like 85%. So profiler, how does profiling and profiling your JVM as well as instrumenting your JVM help us identify bottlenecks? So while you're running your test, depending upon the kind of scenarios and business transactions, you also profile your application. So what profiling actually does is it identifies the actual code as well as actual hot methods. Again, it goes in correlation with the actual heap size, identifying objects in the GC, as well as looking at the timing factor. We did identify for high-level transactions where it was taking more time. And this really helps in identifying the hot methods as well. So earlier I did mention about the actual call traces in terms of some of the SQL. So this particular slide shows for one particular SQL, which was basically bringing up different plans for different age groups. It was making about 56 round calls. And again, the SQL had to be optimized. We had to look into the kind of tables it was joining, multiple joins, and we actually got the number of call counts to like about 4 or 5. Okay. So again, in addition to the previous slide, we also look down into SQL details, and the SQL details tells us, hey, which particular statement in your database was taking more time, what calls were done, what was the time spent. And if you look at the actual 6 seconds, which is 99% of the actual SQL time at the back end, we were spending time making 56 round trips, and this particular slide shows you how many select statements were used, what were the joins, and so on. And as part of this webinar, again, we end the webinar with we looked at how different is it to do performance engineering in cloud, to identifying bottlenecks and how to identify bottlenecks. We walked with about 2 examples. I mean, this is not the only way, but there are a lot of other bottlenecks. So I just want to kind of end this webinar, just give an overview about Zorian Testing Services. We have about 21 years of experience working in full lifecycle business application management, end-to-end testing, support, and migration. We are one of the largest third-party independent offshore testing services. We have office locations in Sunnyvale, India, 2 locations, as well as East Coast. We are more focused on end-to-end testing services for all industry verticals. We have strategic alliance with leading test tool providers. Testing as a managed service for end-to-end testing ownership through our global delivery model. We do on-site, offshore, we do hybrid models depending upon our client requirements. We have a very well established ready-to-use framework both at performance engineering as well as functional automation, and we are a lot of IP in terms of industry-specific COEs. So one thing I want to highlight is as part of this webinar, if any one of you are interested in learning more about performance engineering in cloud, how to identify and optimize your application to meet the growing demands of the market, we offer 1-hour free consultation. So please contact us on the above shown address via email, or you can call us as well. And we'll open up the session for questions. Okay. So one of the questions I have is, what are all the tools used for performance engineering? Again, given the current market trend, I mean, we have various tools. So one is the actual simulation. I mean, we use HP Load Runner. We also use a lot of other performance testing tools like Silk Performer, and we also use the freewares, especially the JMeter and Grinder. And that is just part of the simulation, but then again, there are additional tools which we use. Commercially, we use HP Diagnostics, which helps us in identifying and analyzing our performance both at the middle layer as well as the database layer. And we also use native tools, the native tools in terms of actually running the batch, looking at the CPU memory, and also any core specific batches in terms of the transaction counts and so on. And at the database layer, we also use, again, for SQL, some of the native Oracle tools. So one of the next questions I have is, what are some of the common challenges in performance testing or engineering. See, there are various challenges. Again, depending upon your landscape, one of the challenge would be, given the current agile environment, you constantly move code into the production every week or every other week. So one of the main challenges is keeping up with the releases. I mean, where do you actually start benchmarking and how do you use those benchmarks to iteratively see if there is an impact? So the biggest challenge I see is, again, with the growing, one is the process. You need to have the right process. Time to market is always critical. End of the day, when there is a go, no-go meeting, people always go live to the production from business criticality point of view. But at the same time, having the right balance of the process, right environment, and having the management commitment is one of the key challenges. Okay. So the next question, tell me tools to monitor web monitoring. Again, so there are various tools. I mean, you got to be a little more specific in terms of what do you want to monitor in the web. In case if you are want to monitor just the memory and CPU, again, depending upon whether it's on Linux, Unix, or even Windows servers, you can actually use the native tools. Or you can actually, if you are monitoring specific parameters in terms of the number of threads, number of live sessions, and so on, you can use various tools like Dynatrace, you can use ASP diagnostics, you can also use the New Relic, and so on. But again, what is that you want to monitor is very key in kind of tools you would want to select. So the next question is, would I need the exact production replica from infrastructure point of view to begin the performance testing? Good question. So again, this is very subjective. I mean, given the current stealth mode of most of the startups, ideally, everyone would like to have a production-like environment to actually begin your performance testing. But then again, if you do not have that, you still have to do something. You still have to identify bottleneck. So there are different aspects to look at this particular question. You definitely need an infrastructure close enough to production from a component point of view. When I say components point of view, it is the load balancer, similar load balancer, similar servers, but not necessarily it has to be the same horsepower. For example, if you are having 2 web servers is 4 CPUs each and 16 GB of physical memory, it's not really necessary to have the same setup, same configuration in your performance environment. You can as well have a toned down version of it, definitely not more, toned down version of it like with 2 CPUs and 8 GB of memory and so on. It helps in terms of extrapolating the results based on what you have in your test environment versus what you have in production. The next question, will the slides be available? Yes, we plan to actually send out the slides after this webinar. Okay. So the next question, how is performance testing different between old school architecture versus cloud architecture? What are the top 3 differences? Again, so when we talk about, so I'm going to address this question in 2 parts. One is, what was it in the old school? So when we talk about old school, it's pretty much an client-server architect, I'm assuming. So when we look at hosting any application, earlier it used to be hosted from individual data centers before the cloud actually took place, whereas the cloud service providers like Amazon or even the rack space came into picture. So in that particular setup, the reach in terms of your application, and let's say if you're hosting your application in North America, even though you have certain user base in different parts of United States or even across the globe. So what happens is when you host application, as the users are further away from your physical location or your application, the latency depends. Let's say if you're accessing your application from California, while it is hosted in a physical data center, it's a little faster because the number of hoops an end user takes to reach to your application is a lot lesser as compared to the number of network hoops an user would take if he is accessing the application from elsewhere within the United States or across the globe. Right? So that is one. So from a performance testing point of view, how is that different? From a performance testing point of view, the actual simulation in terms of making sure you create the right set of data. When earlier I talked about geographically locating your actual user load is one of the key aspects, and also the bandwidth, which actually helps us understand the actual pain points of the end users who are located in different regions. That's one. And with the cloud component in place, there are various things. The actual cloud component helps us ramp up the resources from an infrastructure point of view on demand, which gives us a little more bandwidth. And also the number of oops that happens in the system varies depending upon the content servers, depending upon the replica of other servers that has been placed. So again, I think we ran a little over our time. We have come to an end of this webinar, and thank you all for attending the webinar. And if you have any specific questions, please reach out to us via email, and we'll make sure we address your questions. Thank you very much.